Operations with exponents. Evaluate the expression, -3 to the 4th power. If we look at this, the 4, which is the exponent, is only being applied to the base of 3. The 4 is not being applied to the negative sign. So we can rewrite this as -3 to the 4th power. So in other words, we're going to compute 3 to the 4th power and then take the negative of it. If we were to do this without a calculator, we would multiply 3 to itself 4 times. It would equal 3 times 3 times 3 times 3. Then we would get 3 times 3 is 9. And then the other 3 times 3 is also 9. So this becomes -81. And this is our final answer. You can also do this operation on your calculator. The exponent key is usually indicated by an upward pointing arrow or an X to the Y or Y to the X button. You should have one of these on your calculator. Evaluate the expression, 7 to the 0 power. There's a rule of exponents that states that any number raised to the 0 power always equals 1. So 7 to the 0 power is just 1. Simplify using the law of exponents. We have -3 to the 6th power. Now notice the negative sign and the 3 are both being raised to the 6th power. If we were to write this out, this would be the same as -3 times -3 times -3 times -3 times -3 times -3. Then we would just multiply -3 to itself 6 times. So a -3 times a -3 is a positive 9. That's because a negative times a negative is a positive. Again, with the next set, we have -3 times -3, that's a positive 9. And then a -3 times a -3 again is also a positive 9. Now we're left with 9 times 9 times 9. 9 times 9 is 81. And then 81 times 9 is 729. And this is a positive 729. We can also do this on the calculator. If you were to do this on the calculator, you need to encompass the -3 within parentheses. So you should have parentheses buttons on your calculator. You would hit the parenthesis key and then the negative sign, the number 3, and then the other parenthesis key, the exponent button, and then 6. When you push equal to, you should get a positive 729. Multiply 3 squared times 3 cubed. Whenever two exponential numbers are being multiplied together and they have the same base, we can apply the product rule. The product rule says that when we have the same base, we keep the base and add the exponents. For our problem, we'll keep the base of 3 and add 2 plus 3 together in the exponent position. This becomes 3 to the 5th power. Next, we can use our calculator to compute 3 to the 5th power. When we do that, we'll get a value of 243. Evaluate the expression, 2 squared all raised to the 5th power. To solve this, we're going to apply the power rule. The power rule states that when we have a base raised to an exponent and then that whole thing is being raised to another exponent, we keep the base and multiply the exponents together. So here we'll keep the base of 2 and then we'll multiply the exponents of 2 times 5. This becomes 2 to the 10th power. 2 to the 10th power is 1024, so our answer is 1024. Use the rule for exponents to first rewrite the following expression and then evaluate the new expression. 4 squared, all raised to the negative third power. We're going to apply the power rule. The power rule states that when we have an exponential number being raised to another power, we can multiply the exponents together. So we have 4 squared, and this is being raised to the power of negative 3. I'll apply the power rule by multiplying 2 times negative 3. So we keep the base of 4 and then multiply 2 times negative 3 together. And we get 4 raised to the negative 6th power. Now I have a negative exponent. When we have negative exponents, we always need to make the exponent positive by placing a 1 on top of the entire expression. So 4 to the negative 6th power becomes 1 over 4 to the positive 6th power. Now we can use the calculator to do 4 to the 6th power, which is 4096. And our final answer to this problem is 1 over 4096. Divide 4 to the 9th power divided by 4 to the 5th power. We'll apply the quotient rule to solve this problem. The quotient rule states that if we have two exponential numbers with the same base that are being divided, we keep the base and subtract the exponent in the numerator position by the exponent in the denominator position. So, to solve this problem, we'll keep the base of 4, and then in the exponent position, we have 9 minus 5. 9 minus 5 is 4, so now we have 4 raised to the 4th power. When we do this on the calculator, we get a value of 256.